So our fourth question states that hydrogen can be manufactured from methane by steam reforming. The equation is given here clearly. You can see the reaction is carried out using a nickel catalyst at temperatures between 700 degrees Celsius and 1100 degrees Celsius and using a pressure of 180 M. The forward reaction is endothermic. What this means is the backward reaction is exothermic. So now they're asking, part A is asking us to give the simple definition of the term catalyst. So what is a catalyst? In a previous video also I explained about catalyst. So catalyst is a substance that increases the rate of a reaction but is chemically unchanged at the end of the reaction. And you need to know one more important point about catalyst. Catalyst will be chemically unchanged, so mass will stay the same. Okay, so this is a simple definition. You are only required to provide this definition. So your answer for this part of the question will be simply done. Moving on to B part, so there's two reasons why temperature lower than 700 Celsius is not used. So Lee Chatelayer explained his principle in terms of temperature, in terms of concentration, and in terms of pressure. Now what will happen? If we try to increase the temperature, the equilibrium will move in the endothermic side, right? But and endothermic side, and we can see here the forward reaction is endothermic. So if we increase the temperature, it will shift here, and the yield of these products, carbon monoxide and hydrogen, will increase. But now what we are doing is we are decreasing the temperature. And what happens if we decrease the temperature? If we use a lower temperature than 700 Celsius, because 700 Celsius is the optimum temperature. If we decrease the temperature, what will happen? The equilibrium will move in the exothermic side. What happens? What this means? It will move in the exothermic side. It will move in the left side in the backward in the reverse reaction, and the yield of methane and water will increase. And we don't want that. Okay, we want the yield of hydrogen to increase, but the yield of methane and water is increasing. What will happen? We'll say yield of products will be less, and there is also one more reason that if we use a lower temperature, what will happen if we use a lower temperature? The reaction rate would be too slow. Okay, so these are the two reasons you need to mention in your exam. So let me just write here. Firstly, 1 minute. The yield of hydrogen, because hydrogen is the main product we are looking for, will decrease or will be less, and the reaction rate would be too slow. Remember the part B of the question. Moving on to part C. Our part C states asks us to suggest one advantage of using a pressure greater than 1 atmosphere. So whenever they tell you about something, if we increase the pressure, if we increase the temperature, suggest one advantage. So you need to know whenever we increase these three factors, what will happen? The reaction rate will increase. Okay, this is the answer you need to give here. The reaction rate will increase. The rate the rate of reaction will increase. It's simple. If you're familiar with the topic chemical reactions, you need to know what will happen if you are increasing the pressure, if you are increasing the temperature, if you are increasing the concentration. These are the factors you need to be familiar with. Anyways, moving on to the part D. Just one disadvantage of using a pressure greater than 1 atmosphere. So what happened? They are asking us if we increase the pressure. Basically, we are asking only that about if we increase the pressure, what is the disadvantage we are facing? What is the circumstance we are facing here? What will happen if we, it's as mentioned the answer here, higher pressures can be dangerous and very expensive equipment is needed, because to provide that high pressure, we need more expensive equipment, and this is very dangerous. Okay, so this is the simple answer you can write here. Add text, and this was the end of the D part. Moving on to the E part of the question. Hydrogen can be manufactured by Can also be manufactured by electrolysis. The electrolyte is concentrated aqueous sodium chloride. The electrodes are inert. The product of electrolysis are hydrogen, chlorine, and sodium hydroxide. Define it in electrolysis. Okay, so electrolysis, the information I'll give you, but definition we need to create by ourselves own. So you can see here, electrolysis, when an electric current is passed through a molten ionic compound, the compound decomposes or breaks down. The process also occurs for aqueous solution of ionic compounds. It's not a proper definition, but we need to, like, every time I tell you to be creative with words. In IGCS, you need to be very creative with words. So how we'll write the answer depends on your creativity. So I'll just show you how I will write the answer. So it will be, I can write answer, electrolysis, electrolysis, electrolysis is the decomposition, decomposition of an ionic compound in molten or in aqueous state, in molten or aqueous state, or aqueous state, right there, or aqueous state by the passage of electric current. Look how perfect is this sentence. So basically, you need to practice these type of questions so you can get expert at writing these answers. Anyways, moving on to the part two of this part. Name a substance that can be used as the inert electrodes. So inert electrodes, what in electrolysis basically we are using unreactive electrodes because we don't want them to react with the atoms, with the ions present in the electrolyte. What will happen if the anode, you need to be familiar with this statement, okay? So whenever we are, the second statement refers to the what we say, the electroplating. Electroplating, if we are doing electroplating, then we can use the electrode as a reactive metal. But if we want to use the electrode as inert, so we can use graphite or platinum because these are very unreactive, and the ions will lose electrons to the anode to form a non-metal or oxygen gas. Same occurs for cathode. So we can use graphite or platinum. Among these, I can write one of them. Graphite. I can write here graphite, right? Graphite is okay. Graphite. Carbon also you can write because carbon, the question came of diamond and graphite allotropes of carbon. So you can write carbon also. But I'll prefer writing graphite because most of the time in our school we used to use graphite mostly. Yeah. Moving on to part 3 of this question, write an ionic half equation for the reaction in which hydrogen is produced. So basically, you should be familiar with the electrolyte first. So electrolyte, you can see here, concentrated aqueous sodium chloride. What will happen if the electrolyte is a concentrated? So Cl minus is probably produced at the anode, and hydrogen is produced at the cathode because the least reactive will easily lose, okay, will easily lose its electrons. That's why hydrogen will come. I'll show you the table I have prepared here. The answer also is given there. Let me just show you. Yeah, you can see here clearly. So basically, we are not looking for any of these. We are just looking for the first one, concentrated sodium chloride. So what will happen? You need to show the ions present here. So ions from the sodium chloride also present, Na plus plus Cl minus, and ions from water is also present because it's an aqueous sodium chloride, concentrated aqueous sodium chloride. Aqueous means dissolved in water. So H plus and OH minus also. Now what will happen? What will happen now? We are looking for the ion which will easily lose its electrons. And in the reactivity series, we can see hydrogen is below sodium. So it's the least reactive, so it will easily lose its electrons, and the more reactive will remain in the solution. So H plus will discharge at the cathode and it will release as a gas. So this is the equation. You need to be familiar with the cathode reaction. 2H plus 2E minus will give you hydrogen. And among these also, there is a series, but there is a most reactive to least reactive series for all the ions. I'm not showing that, but whenever they ask you about concentrated sodium chloride, so concentrated means always Cl minus will be discharged at the anode. So your equation will be 2Cl minus will produce Cl2 plus 2E minus. But then now they're asking only for cathode, so I'll mention only this equation. 2H plus 2E minus will produce H2. So our answer for this question will be, a minute. Yep. Yeah. 2H plus, sorry, 2H plus 2E 2E minus will produce H2. Okay, great. Where is hydrogen produced in the electrolytic cell? Okay, so you basically they're asking you to mention the name of the electrode at which hydrogen is produced, so we can see it's produced at the cathode, right? Simple answer. 1 mark question. No details required. 1 minute, guys. Yeah, no, it's perfect. So it's produced at the cathode. Moving on to the next part of the question, describe a test for chlorine. There is a simple test for chlorine you need to be familiar with. So here I'll show you the test. Um, 1 minute. Yeah, you can see here clearly. The test is the damp blue litmus paper. You need to it's like a type of universal indicator. So you will add it's an indicator. So damp blue litmus paper we will add to the test tube, and the result will be it bleaches. The chlorine will bleach that damp blue litmus paper, so it will decolorize. So we can just write as it is this statement. So 1 minute, guys. Yeah, add here text. Perfect. Great. Done. Moving on to the part F. The electrolysis of concentrated aqueous sodium chloride can be represented by the following word equation. Construct a chemical equation to represent this reaction. Sodium chloride plus water will produce sodium hydroxide plus hydrogen plus chlorine. So we need to know the chemical formulae of each of these compounds and elements. So the sodium chloride will be NaCl plus H2O will produce NaOH plus H2 plus Cl2. And I think we should balance also it because it's a, yeah, it's a Zuma question. We also need to balance it. So I've already balanced in this document. I'll show you. Yeah, now it's perfect. This is the balanced chemical equation you need to mention in your exam. I'll be making further videos, upcoming videos. After solving the past papers, I will be making videos to you for explaining the how to balance these equations because most of you are confused in these type of questions. Anyways, let's stick to the question. So our answer for this question is this. Yeah, great. Then with the F part, G part. State one use of chlorine, sodium hydroxide, and hydrogen. Okay, so you need to be familiar with these. Actually, it's for chlorine has a common use. Okay, because from like I think I'm hearing from grade 6 that chlorine is used to um, treat water like impurities to remove impurities. It is used to clean water and make it drinkable. So this is the answer you can write here. Okay. I think most of you would know what is the use of chlorine. That so there are many uses actually. You can write any of those. It does not involves any sort of calculation or any sort of specific answers. There are many more uses, and you can just write any of those. But I'll prefer writing this clean water make it drinkable because the common use I've heard of is this. Moving on, sodium hydroxide. Sodium hydroxide. Actually, I didn't heard it before. It was used in detergents. So in washing powders or detergents, you can use this. Washing powders, I'll prefer writing. Hydrogen. Okay, this one we did before. If you remember the manufacture of ammonia, about the Haber's process, what will happen? Hydrogen will react with nitrogen to this one. Hydrogen will react with nitrogen to produce ammonia. So basically, we are using it in the manufacture of ammonia. Manufacture of ammonia. You need to be familiar with the Haber's process for this. There are many more uses. I'm telling you again. You can write any of those. Okay, moving on to the fifth question. Hydrocarbons are compounds which contain hydrogen and carbon only. 10 centimeter cubed of gaseous hydrocarbon CXHY Basically, we need to find these are numbers we need to find. Are burned in 100 centimeter cubed of oxygen, which is in excess of oxygen. This means there is more than enough oxygen we have. After cooling to room temperature and pressure, there is 25 centimeter cubed of unreacted oxygen, 50 centimeter cubed of carbon dioxide, and some liquid water. All volumes are measured under the same conditions of of temperature and pressure. Part 1. What is meant by an excess of oxygen? This is a simple definition you need to know. The simple definition of this is more than enough to react with. Actually, you might be familiar with this type of definition because it comes mostly in exams. More than enough to react with all the hydrocarbon. Actually, it's given marking scheme also. And the simple IGCSE also has given this definition in the notes. If you're familiar with it, your teacher also might be giving you. This is the answer you can write here. Anyways, moving on to the next part of the question. What was the volume of oxygen that reacted with the hydrocarbon? Okay, so you might be thinking we need to use the equation volume equals moles divided by 24. That's not the correct way of doing this. It's a 1 mark question, remember? No calculation involved. So if what was the volume of oxygen they are asking that reacted with the hydrocarbon? Okay, it's a simple answer. Firstly, check the first statement. What information they had given you about oxygen? Okay. 10 centimeter cubed of gaseous hydrocarbon, this is the hydrocarbon, are burned in 100 centimeter cubed of oxygen, which is an excess of oxygen. So in total, what volume of oxygen we have is 100 centimeter cubed. After cooling to room temperature and pressure, there is 25 centimeter cubed of unreacted oxygen. So there was, after we cooled it to room temperature and pressure at RTP, there was 25 centimeter cubed of oxygen that didn't react. Okay, so what this means? Easy answer. We will subtract the unreacted oxygen from the total volume of oxygen, which is 100 minus 25. So 100 minus 25 will give us 75 centimeter cube. Easy answer. Easily score 1 mark. Okay, 100 minus 25 equals 75 centimeter cube. Great. Third part, complete the table to below to express the smallest whole number ratio of volume of hydrocarbon reacted is to volume of oxygen reacted is to volume of carbon dioxide reacted. Okay, what was the volume of hydrocarbon reacted? We need to check first. So volume of hydrocarbon was 10 centimeter cube. You can see clearly here is given in the question. Okay, let me just go down so I can show you how we'll write it. We just will write 10 here because they're asking only with the volume, no moles required. 10 centimeter cube. And volume of oxygen, we find it in the second part of the question, which was 75 centimeter cube, right? This answer for the 75 centimeter cube. Okay. And volume of carbon dioxide, they also give us in the third part, in the second step they give 50 centimeter carbon dioxide. This was the volume of carbon dioxide. Okay, but what we need to do now, we're not over yet. I'm just showing you this. Actually, you don't have to write these values in these boxes. The values are very different. We need to check the smallest whole number ratio of the volumes. So we need to check in which table these all numbers will divide. I think they can be divided in the fifth table. Yeah, because last number is 0, last number is 5, last number is 0. Yeah, they can be divided. So fifth is 10 divisible by 5. Yes, it's divisible by 5. So 5 times 2. So this will be 2. 75 is divisible by 5. So let me just check. 75 divided by 5 is 15. So this answer will be 15. Volume of carbon dioxide, 5 tens are. Okay, 5 tens are 50 divided by 10 is 50 divided by 5 is 10. This is the answer. This is the smallest whole number ratio of their volumes. I hope you're getting it. Okay, use your answer to A3, or this is the A3, the molar ratios. To find the mole ratio in the equation below, complete the equation and deduce the formula of the hydrocarbon. Okay, this is a tricky question, 2-mark question, right? So first, let me just write here. Okay, so basically we have found we don't know any of these molar ratios. We don't have anything. We should write the numbers. We should fill these. You can see the lines, the blanks with numbers. So how we'll do that? So firstly, I'll just right here. So this is the hydrocarbon. And what was the volume of the hydrocarbon? Let me just tell you. It was volume of hydrocarbon was 2. Okay, because we are looking for A3. They're asking us to use your answer to A3. Okay, so volume of hydrocarbon was 2, and I'll write here CXHY plus O2. Volume of oxygen was 15, right? It was 15 O2. Sorry, I wrote 0. 1 minute. O2. O2. This will produce CO2. Volume of carbon dioxide produced was 10. Okay, you can see here. You can see this is the molar. This is the mole uh, ratio of moles, the ratio of volumes you can see here. So we are using our answer. We are utilizing the answer to complete this equation, and we can also find the formula of hydrocarbon. Okay. Now this will produce 10 CO2 plus. Now finally we need to find water, and we don't have any information about water. So how I'll find that? Now to find 1 minute, to find the water, about water, what we'll do, we will check. Okay, so let me just check how many we need to. Okay, so for this is the trick for this, we need to know how to balance the equation. So here you can see there are 30 oxygen atoms, yeah, the reactant side, and there should also be 30 oxygen atoms in the product side, right? So we have 20 oxygen atoms here, and this means we should have 10 oxygen atoms here, right? So our answer we can write as 10, and we can also okay, this is the answer for this. So you can see clearly here we have 30 oxygen atoms in the reactant side, and now they are equally balanced because we have written 10 in front of oxygen here. So 10 multiplied by 1 oxygen atom is 10, and here also we have 20 oxygen atoms because 10 multiplied by 2 is 20, 20 plus 10 is 30. It's balanced. Now what we need to do, we need to know the formula of this hydrocarbon. Okay, we have completed the molar ratio in the equation below, and we have scored 1 mark. Now other mark is also precious, we also need to score it. Well, now what we'll do, we need to find the formula of this hydrocarbon CXHY. What are these X numbers, Y numbers? Very confusing. So how we'll do that? So now firstly we look at the reactant side, right? And we solve the product side. Now we will compare this product side with the reactant side. You can see it. Now firstly you need to check how many carbon atoms are present. Okay, there are only 10 carbon atoms present, right? Okay, and here they have given us 2. This 2 is mentioned here. Now this 2 will multiply by what to give us 10? Okay, this 2 will multiply with what to give us 10? So we can just use some mathematics here. This right here. So this 2 will multiply with this x, and it will give us 10. This means x will be equal to 10 divided by 2. Give us x equals 5. This is the value of x. Okay, now we need to find the value of y. Find the value of y, which is for hydrogen. Basically we are finding for hydrogen. So we first need to check in the product side how many hydrogen atoms we have. We have 20 hydrogen atoms, right? You can see clearly here we have 20 hydrogen atoms. Now we need to check with 2 what number will multiply to get 20. So we can use that equation like this: 2 multiplied by y equals 20. This will be y equals 20 divided by 2, y equals 10. So we have got an answer for the values of x and y. So x value will be 5 and y value will be 10. I hope you're getting it. This was a bit tricky question, but you can practice this question. This will become surely easy. I promise you. Okay, so we can write our answer CXHY. Instead of x, we can write, instead of x and y, we can write the values have we have found out. So C5 and H10. Easy question. B. B, not B. Cracking is used to convert long chain alkanes into shorter chain alkenes and alkenes. Alkenes are unsaturated compounds. Decane C10H22 can be cracked to give propane and one other product. Complete the chemical equation. Okay, whenever they give you this type of question, okay, they'll give you one product, they give you one reactant, it is decomposing into one product and one more product which we don't know. So how will find now? Actually, it's this product is a hydrocarbon, but we don't know what are the numbers of the carbon atoms. So what we can do here, we can write firstly C and H. That we know that it's a hydrocarbon, right? So we can write here is C and H, and this value we need to specify. Okay, so this value will be the difference of this carbon atom, the reactant carbon atom, and the product carbon atom. This will be 10 minus 3. So the leftover carbon atom is 7. So our answer for this carbon atom will be 7. And similar, likewise for H. For H also we need to find the difference between the reactant hydrogen atom and the product hydrogen atom. 22 minus 6, then this step will just 22 minus 6. 22 minus 6 is 16. So this answer will be, hydrogen atom will be C7H16. Okay. I hope you're getting it. What is meant by the term unsaturated? Okay. This is a question from organic chemistry from alkenes and alkenes. Okay. So this is the answer for your question. Compounds that have carbon-carbon double bond are called unsaturated compounds. Easy question, no calculation involved, not a complex question, simple question. Okay, this answer as it is, we can write here, compounds that have a carbon-carbon double bond are called unsaturated unsaturated compounds, sorry. Describe a test to show the propane is an unsaturated compound. Now I will give you a detailed test for this, okay? Then I will tell you which answer you need to write. Okay, so you can see here this above part. I just highlighted so you are familiar with the steps. That is extreme here. Perfect. Okay, so bromine water, we are using bromination process some here. We are doing aqueous bromine. So bromine water is an orange colored solution of bromine, and we are looking, it's an alkene, right? Let me just check. Okay, we are testing with a propane, it's an alkene. Okay, when bromine water is shaken with an alkene, okay, its initial color bromine is orange colored solution, bromine water. And when this orange colored solution, this bromine water, is shaken with an alkane, not alkane, it will remain as an orange solution, as alkenes do not have a carbon-carbon double bonds. This means they are saturated compounds. The bromine remains in solution. But there is a condition. But when bromine water is shaken with an alkene, okay, it's similar for this question. It's a propene alkene, right? Alkene will decolorize the bromine water, and then colorless alkenes do have carbon-carbon double bonds, and this means they are unsaturated. The bromine atoms add across the carbon-carbon double bonds. Hence, the solution no longer contains the orange-colored bromine. The reaction between alkenes and bromine is called an addition reaction. Okay, this is the detailed step. I hope you understood very well. But now we are looking for the test we are looking. So we can say bromine water shaken with alkene. Okay. Basically, we're talking about propene, so I'll just replace alkene with propene. Let me just write here. Bromine water is shaken with propene. What is the result? Result is mentioned in itself. The steps. Result will be the alkene, the propene will decolorize the bromine water and turn colorless. No reason is required, only the result is required. This is your answer. Propene. Replace the alkene with propene. Propene. Great. Okay. Moving on to the C part. Propene can be polymerized. The only product is polypropene. The equation for the polymerization is given here. You can see here. It's a similar Okay, it's a polymerization reaction. So whenever they give you this type of question and they have given you brackets and there are hydrogen atoms, you can see here um, polypropene they have given here. So whenever they involved poly something, whenever they involve like is polypropene or your is similar to your reactant. For example, if it's ethene, it will give you polyethene. If it's chloroethene, it will give you polychloroethene. So this type of reactions are always called addition reactions. Okay, I hope you're getting it. Actually, I'm trying to clear your all the doubts, clear all the obstacles for you, so you are familiar. So it's easy for you to solve this type of question. Part two, there is a maximum mass of polypropene that could be produced from 1 kg of propene. So you need to know one thing. Whenever, whenever an alkene is polymerized, okay, whenever this, so in term, now we're talking about propene, whenever this propene is polymerized, it will give you polypropene. So the before polymerization and after polymerization, its mass will stay the same. So we need to say 1 kg of polypropene. Simple answer, simple question, simple answer. Give the empirical formula of propene. Okay, empirical formula of propene. What is the empirical formula of propene? Okay, you might be thinking that don't have any mass, no volume. It's not about that. Empirical formula, from the definition itself, you need to know what is that. Okay, it's the simplest whole number ratio, simplest. Okay, now you can see here, if this is the formula of propene, this is the formula of propene, C3H6. Now, tell me in which table you can divide these both. I think it 3 is table, they can divide both. So we'll divide 3 by 3, 3 divided by 3 is 1, and 6 divided by 3 is 2. So we can replace these. This will become as CH2. CH2, simplest whole number ratio, right? Correct, perfect. This is the answer you need to give. Right here, CH2. Give the empirical formula of polypropylene. This is a bit, they're trying to confuse you in this question. You might be thinking, oh, I don't know what is polypropylene. They are not given only the information about propylene. What is that? Don't be confused. As I told you before, the before polymerization and after polymerization. Addition, we're talking about addition polymerization. Its mass will stay the same. This means it will contain the same, like it has the same empirical formula. Okay. Don't be confusing this because it's not that hard. Just look at the question carefully, read it, and then answer it. Oh, just 1 minute. 1 minute, two, yep. And right here, CH2 again. Okay. Simple question, simple answer is required. No complications, right? Moving on to the last part, last question, sixth question. Zinc is extracted from an ore called zinc blend, which consists of A of zinc sulfide in it. Zinc sulfide in the ore is first converted into zinc oxide. And describe how zinc oxide is made from zinc sulfide. So, describe how zinc oxide is made from zinc sulfide. Let me just check. In the process of zinc extraction, you need to be familiar. It's related to the chapter extraction and use of metals. You need to be familiar with the chapter. So, firstly, let me just read out the process of zinc extraction. Zinc ore is called zinc blood, ZNS. The zinc blood is first converted to zinc oxide by heating with air. Okay. Explain how zinc oxide is made from zinc sulfide. This is the reason. This is your answer. It is converted by heating with air. Okay, this is the answer you need to mention for this part of the question. Okay, so by heating with air, by heating with air. Write a chemical equation for the reaction in A1. Okay, so this is the chemical equation also given. You might have. Okay. This is the chemical equation. Chemical equation, you need to balance it. Okay, it's a 2-mark question. Yeah, it's a 2-mark question, right? So it's a 2-mark question. You need to balance the chemical equation whenever you are. Whenever we're writing a chemical equation, you also need to balance it to score 2 marks. Zinc. Oh, 1 minute, guys. Yeah, zinc oxide is converted into zinc. Okay, so let me just check. zinc oxide. Let me just check. Zinc oxide is converted into zinc, correct? Zinc oxide and coke, then O plus CO, C. Zinc oxide and coke, carbon they're talking about, right? And coke are fed into a furnace. Hot air is blown into the bottom of the furnace. Zinc oxide has a melting point of 420 Celsius and a boiling point of 907 degrees Celsius. The temperature inside the furnace is over 100,000 Celsius. Explain how zinc oxide is converted into zinc. Your answer should include details of how the heat is produced and equations for all the reactions you describe. Okay, guys, there are some points you need to mention. So, firstly, your mark will be for the three equations. 3 mark question. This means three equations you need to mention. So, firstly, what happens is carbon burns in a blast of very hot air. Hot air, oxygen, like the oxygen, we are blowing hot air, which contains oxygen. So, oxygen from the hot air will react with carbon, and this will form carbon dioxide, which is an exothermic reaction. And explain in the previous below also, explain in the previous reaction for the blast furnace also I told you, right? For the previous paper, it was 0620 paper 43, right? May June 2016. Yeah. What happens in exothermic reaction? It releases a lot of heat energy. Okay, one, how the heat is produced. This is the reason. Now, the carbon dioxide produced this react with more coke to form carbon monoxide. Now, this carbon monoxide is a reducing agent and it reduces the zinc oxide to zinc. This is the complete answer which you need to follow to score the 3 marks. Okay, moving on. Explain why zinc produced inside the furnace is a gas. Okay, so for this part of the question, why zinc produced inside the furnace is a gas, you might have heard about the heating curve. So what happened when the temperature, this temperature of the furnace in which zinc is being produced, pure zinc is being produced, is above the boiling point of the zinc. What will happen? Zinc will turn into gas. If it's above the melting point, it will turn into a liquid, obviously. But if it's above the boiling point, okay, then it will turn into a gas. So we can say temperature in furnace is above BP of zinc. Correct? State the physical change for conversion of gaseous zinc into molten zinc. This means you have to mix. Let me just tell you what is the. I'll just tell you the physical change for the conversion of gaseous zinc into molten zinc. So you should be familiar with the heating curve as well as the cooling curve. So when we are basically gaseous into molten, molten means liquid. Okay, gas into liquid. What does this mean? Tell me. You need to be. You have 2 seconds. So when we are changing to gas into a liquid, it means it is a process of condensation. We are condensing it. So we can write here condense or condensing. I prefer writing condensation because the process condensation. Perfect. Moving on to the next question. 1 minute, guys. Yeah. Okay. Part C, rusting of steel can be prevented by coating steel with a layer of zinc. Explain in terms of electron transfer. Why steel does not rust even if the layer of zinc is scratched, the steel is exposed to air and water. So it's a 4 mark question. This is the definition. This is the complete detail is given. Then I'll tell you afterwards. I'll tell you what answer you need to write. Okay. So zinc is more reactive than iron, so it loses its electrons more readily. The iron stays protected as it accepts the electrons released by zinc, remaining in reduced state and thus it does not go under oxidation state. Okay, so the electrons donated by the zinc react with the hydrogen ions in the water producing hydrogen gas. Zinc therefore reacts with oxygen and water and corrodes instead of iron. So 4 mark question, you can write this 4 statements. Okay, actually you are asked to write not the other two are extras, but to complete our text we can follow this answer. Okay. So um, equations options you can give or no, it's your choice. Okay, so this is the answer you need to go through. Part D. When a sample of steel is added to dilute hydrochloric acid, an aqueous solution of iron 2 chloride FeCl2 is formed. When a sample of rust is added to dilute hydrochloric acid, an aqueous solution of iron 3 chloride FeCl3 is formed. Aqueous sodium hydroxide is added to the solutions of iron 2 chloride and iron 3 chloride. Complete the table below by showing the observations you would expect to make. So when we are adding aqueous sodium hydroxide to iron 2 chloride solution, what we will observe? So you need to be familiar with the topic of identification of ions and gases. So this is the, here you can see here, we are adding, so you can see this table, we are adding aqueous sodium hydroxide and adding ammonia solution. We are looking for now the aqueous sodium hydroxide. So you can see here clearly that we are adding aqueous sodium hydroxide. So I think it's Fe2 plus or Fe3 plus. Let me just check. It's Fe2. So we're adding to this ion basically. So the when we're adding to Rn2 chloride, so the answer, so the observation will be a green precipitate. Okay, so it will be a green precipitate. Okay, because it depends on the ions. So we'll get the color. So green precipitate we can see. Green precipitate. And when we are looking into iron 3 chloride solution, we can see here Fe3, this ion you can see, we will get, if you are adding aqueous sodium hydroxide, we will get red brown precipitate. Okay, so our answer we can write as red brown precipitate. Red brown precipitate. This is the answer. Now it's the last part of the question. This is the last page of the question. Solutions of iron 2 chloride and iron 3 chloride were added to solutions of potassium iodide and acidified potassium manganate 7. The results are shown in the table. Potassium iodide solution. Iron 2 chloride, when it was added to iron 2 chloride, it had no change. But when it was added to iron 3 chloride, it turned from colorless to brown. When we added acidified potassium manganate 7 solution to iron 2 chloride solution, it turned from purple to colorless, but with iron 3 chloride solution, it was in no change. Which type of substances causes iodide solution to turn from colorless to brown? Okay, for this question, yeah. Okay, whenever you give I'll just give you a hint. For this question, you can see when we are, this question states that what type of substance causes potassium iodide solution to turn from colorless to brown? Okay, it is changing from colorless to brown. This means it is an oxidant. Okay, oxidizing agent. Oxidant is causing this potassium iodide to turn from colorless to brown. Okay, so I'll prefer writing oxidant. So oxidant. You can also write oxidizing agent, depends on you. Which type of substances causes acidified solution to turn from purple to colorless? Now, in the second part, you can see it's gaining color. Okay, it's gaining a color. This means it is getting oxidized. It's an oxidant. And the next part of the question, what type of substance causes acidified potassium manganate 7 solution to turn from purple to colorless? It's losing its color. This means it is getting reduced. Okay, this is a reductant, right? And I hope you're getting me. So you can just make estimations of these. So it's a reductant. There's something going on our mic. I hope you're not getting disturbed. Reductant. Okay. Which ion in iron 3 chloride solution causes potassium iodide to turn from colorless to brown? Okay, it's a direct question, straightforward question. Okay, you can see which ion in iron 3, they're asking about ion in iron 3 chloride solution causes potassium iodide from colorless to brown. Iron 3 chloride. So it's Fe3 plus. Iron 3 plus. Fe3 plus we can say is the answer for this question. So Fe3 plus we can write here. Fe3 plus. Moving on to the last part of the question. Which ion in iron 2 chloride solution causes acidified potassium manganate 7 solution to turn from purple to colorless? It's losing its color, reducing agent, so we can say Fe2 plus. Because you can see iron 2. Iron 2 is the ion, right? Fe2 plus, simple. Fe2 plus we can write it. Fe2 plus. This was the end of the examination. I hope you liked the video. Please don't forget to subscribe my channel and press the bell icon to stay tuned for more videos. And also press the like button and share with your friends, and also ask them to subscribe. It will be very grateful. It will be very helpful to me if you subscribe my channel, if you support me, so I can create more videos like this, so our students also can, even at the lower level, the student can upgrade from a lower level to a high level. That's why I am creating these videos. Thank you for watching my channel. We'll meet in our next video.